to transmission lines and waveguides. So here, I'm going to discuss input impedance of transmission line. So what is reflection coefficient, what is VSWR. So I will explain short circuit lines, open circuit lines, matched line. So what is infinite line, what are the characteristics of lambda by 8, lambda by 4, lambda by 2 lines, Smith chart matching techniques. So here input impedance of transmission line. So by taking voltage and current equations, so here we are going to by taking voltage and current equations, here we got input impedance of transmission line. So here for lossless line, gamma equal to G beta. So input impedance of transmission line Z0 into ZL plus JZ0 tan beta L by Z0 plus JZL tan beta L. So here ZL is load impedance. So here ZL is load impedance, Z0 is line impedance, characteristic impedance of transmission line. So when beta L is electrical length of transmission line in radians. So here by saying this equation, you can say input impedance of transmission line varying periodically with distance L from the load. So it is the input impedance of transmission line in terms of reflection coefficient, that is Z0 into e power gamma L plus gamma L into e power minus gamma L by e power gamma L minus gamma L into e power minus gamma L. So what is reflection coefficient? So here reflection coefficient, voltage reflection coefficient at any point on the line is the ratio of magnitude of the reflected wave, voltage wave, to that of incident wave. So at the load, reflection coefficient gamma L equal to V0 minus e power gamma L by V0 plus e power minus gamma L. V0 minus V0 plus, these are voltage of reflected wave, incident wave. Minus means reflected wave, plus means incident wave. So reflection coefficient at the load, gamma L equal to ZL minus Z0 by ZL plus Z0. So current reflection coefficient at any point on the line is the negative of voltage reflection coefficient. So coming to standing wave ratio. Standing wave ratio is ratio between maximum voltage or current to minimum voltage or current of standing wave. S equal to V maximum by V minimum or I maximum by I minimum. So if standing wave ratio is expressed in terms of voltages, then it is called as voltage standing wave ratio, VSWR. So here VSWR equation in terms of reflection coefficient, that is equal to 1 plus mod gamma L by 1 minus mod gamma L. So range of VSWR and reflection coefficient. So reflection coefficient is ranging from minus 1 to 1. VSWR is ranging from 1 to infinity. So coming to short circuit transmission lines. So short circuit transmission line means here load impedance ZL equal to 0. So then input impedance of short circuit transmission line, that is equal to JZ0 tan beta L. For short circuit transmission line, VSWR equal to infinity, reflection coefficient equal to minus 1. So here it is the input impedance of short circuit transmission line versus length of transmission line. So here this these are the equivalent models for short circuit transmission line. Suppose the length of shorted line less than lambda by 4, then it is equivalent to inductor. In between lambda by 4 and lambda by 2 is equivalent to capacitance. That means you can use these type of short circuit or open circuit transmission lines as lumped elements. Coming to open circuit transmission line, ZL equal to infinity means input impedance of open circuit transmission line, that is equal to minus jz0 cot beta L. So gamma L equal to infinity 1, VSWR equal to infinity for open circuit transmission line. It is the input impedance of open circuit transmission line versus length of transmission line. So these are the equivalent models for open circuit transmission line. Matched line. Matched line means here matching condition is ZL equal to Z0. So here matching condition ZL equal to Z0 means so reflection coefficient 0, standing wave ratio equal to 1. That means there is no reflected wave. Entire wave is traveling along the line from source to load without any reflection. If ZL equal to Z0, if load impedance equal to line impedance, there is no reflected wave along the transmission line. So maximum power transfer is possible when transmission line is matched to load. So infinite line. So for infinite line, here so these are the equations, voltage current equations for infinite line. If a line of infinite line length is considered, then all the power fed to into it is absorbed. So coming to lambda by 8 line, so input impedance equation. So coming to lambda by 4 line, quarter wave line, so input impedance equal to Z0 square by ZL. So here significance of quarter wave transmission line. Suppose load impedance 0, input impedance infinity. Suppose load impedance very high, say infinity, input impedance 0. That means quarter wave line can transform a low impedance to high impedance and vice versa. That means you can use this quarter wave transmission line as impedance inverter. Half wave line. So for half wave line, input impedance directly equal to load impedance. Whatever impedance across load, that impedance directly reflecting it input side. It means you can use half wave line as impedance reflector. So power in a transmission line, so that is V naught square by 2 Z0 into 1 minus gamma L square. Suppose reflection coefficient equal to 1. That means there is no power transfer along the line. Suppose reflection coefficient 0, so entire energy, that incident power is entire incident power that is transmitted along the line. So coming to Smith chart. So Smith chart is graphical indication of impedance of transmission line as one moves along the line. So here entire Smith chart is constructed on unit circle. So it is a construction of Smith chart. So these are the R circle, X circle equations. So from R circle, X circle equations, Smith chart is constructed. So these are the R circles and X circles. So R equal to 0 circle, it is outside outermost circle. R equal to 1 circle passing through center of Smith chart. So next X circles. So X equal to 0 circle, it is horizontal line. X equal to 1 circle. Here X is either positive or negative. R is always positive. X is either positive or negative. X is positive means that is related to inductive reactance. X is negative means that is related to capacitive reactance. So these are combination of R circles and X circles. So Smith chart is combination of R circle and X circles. So here it is a real Smith chart. So here entire Smith chart, the Smith chart. So total circumference is we are moving around Smith chart means so entire here the total circumference is 0.5 lambda. So here moving towards generator, moving towards load. That indication is visible in the Smith chart. So here in the Smith chart, above half represents inductive reactance, below half represents capacitive reactance. It means capacitive circuits, capacitive reactance. So using Smith chart, you can easily find out input impedance of transmission line, VSWR, reflection coefficient, also position of Vmax mass, moving mass, position of stub. You can easily calculate using Smith chart without any tedious calculations. You can easily calculate all these parameters. So coming to quarter wave transformer, it is a quarter wave line. So quarter wave transformer, it is one matching technique to match load impedance and line impedance. So here, so quarter wave transmission line that is inserted between main transmission line and load. So here quarter wave transmission line is designed with input impedance equal to Z0, and that means quarter wave transmission line is designed with line impedance is equal to square root of main line impedance and load impedance. So automatically input impedance of lambda by 4 line is equal to Z0. So there is matching between the main line and this load. So it is the without lambda by 4 line, with lambda by 4 line. That is the so with lambda by 4 line, almost entire energy is transmitted from source to load without much reflection. So stub matching. Stub is one transmission line. It is either short circuited or open circuited transmission line, useful to match match main transmission line and load. Short circuit stubs are preferable than open circuit stubs because of infinite terminating impedance is more difficult to realize than zero terminating impedance. Also radiation is more in open circuit stubs. So here use of open or closed stub line of suitable length as a reactance shunted across transmission line at suitable distance from the load to tune the line, and load is called stub matching. So here stub is placed at particular distance from load and with particular length that is useful to match load and main line.